Imagine an alternative reality where your car is powered solely by air. Yes, you heard correctly. Air. Now, as much as that sounds like science fiction, recent groundbreaking innovations in the engineering sector, coupled with sheer commitment, have proved otherwise. As the world continues to find alternatives to greenhouse gas emissions and mitigate climate change, the need for a cleaner, greener engine has never been greater. As many technologies emerge, air engines are a prospect that stands out the most. Air engines, also known as compressed air engines, offer a cleaner option compared to traditional internal combustion engines that rely on burning fossil fuels. Instead of gasoline or diesel, these engines use compressed air as a means to generate power. The result? A potentially zero-emission vehicle that could revolutionize not only the automotive industry, but also a wide range of industrial applications. Imagine a car that, instead of producing harmful exhaust gases, releases nothing but the very air it took in, without any pollutants or carbon dioxide. The concept of using air to power engines might seem simple, but it involves a deep understanding of thermodynamics and engineering. Over the past few decades, scientists and engineers have made significant strides in developing more efficient ways to compress, store, and utilize air for power. Today, air engines no longer seem like an impossible task, with several prototypes already in development and some even hitting the roads. The idea of producing a working air engine is simple: use compressed gas to generate mechanical work. The basic principle involves compressing a gas and storing it in a tank, almost like hydrogen-powered cars. When the gas is released, it expands and drives a turbine or piston, which produces motion that can then be used to power a vehicle, machinery, or even generate electricity. However, the most intriguing part about these air engines is their potential to eliminate emissions. Unlike traditional petrol-powered engines that burn fossil fuels and release harmful greenhouse emissions, these air engines simply release the air that was initially compressed, resulting in a byproduct which is, you guessed it, air. The concept of air-powered engines isn't entirely new. Pneumatic motors, which operate on a similar principle as the highly anticipated air-powered engines, have been used in countless industrial applications throughout the years. With the help of recent studies and technological advancements in engineering, we've enabled automakers to use this technology in the automotive sector, taking a big leap in the direction toward a green future. The innovation of air-powered engines lies in the sophisticated engineering required to efficiently compress air and store it, as well as in developing mechanisms that convert the compressed gas into usable mechanical energy. Companies like General Motors have been working on developing air engines for vehicles that utilize axial flux motors, which are compact, lightweight, and highly efficient. These motors are particularly suited for automotive applications because they can be integrated into a vehicle's design without adding significant weight or complexity. They've been experimenting with designs that combine compressed air technology with electric motors to create a hybrid system that maximizes efficiency and sustainability. The main idea is to use compressed air for initial acceleration and low-speed driving where its efficiency is highest, then switch to an electric motor for higher speeds or when more power is needed. Air engines can be one of the most crucial alternatives to our petrol engines, and their potential benefits are numerous and extend far beyond just environmental conditions. Their most significant advantage is being able to successfully put an end to greenhouse gas emissions. The potential to emit no product other than air makes them a viable alternative to gas-powered engines. Moreover, compressed air is relatively abundant, almost like hydrogen, but also inexpensive to produce. This makes the operation of air engines potentially more cost-effective in the long run. Additionally, the simplicity of the engine design means lower manufacturing and maintenance costs, which could translate to lower car prices in the future. Air engines have fewer moving parts than traditional internal combustion engines, which reduces the likelihood of mechanical failure and makes them easier to maintain. This simplicity could lead to increased reliability and a longer lifespan for vehicles equipped with air engines. Air engines do not use flammable fuels, which can make them safer in certain situations, such as in the event of an accident. Additionally, because they operate at cooler temperatures, there's less risk of overheating and related issues. Now, although the potential benefits of air engines are compelling, several challenges need to be addressed before they can become a mainstream technology, with the primary challenge being the amount of energy required to compress air to the necessary pressure levels. Compressing air to the high pressures needed for an air engine to function efficiently requires a significant amount of energy. If this energy is sourced from non-renewable sources, it could offset some of the benefits of air engines. Hence, it's crucial to realize that the full potential of air engines lies in using renewable energy sources such as solar or wind power to compress the air. Another challenge lies in the method of storing compressed gas. High-pressure tanks need to be extremely durable to contain compressed air, hence they must be designed to withstand high pressures without leaking or bursting. Additionally, the materials used for these tanks must be lightweight yet strong, which can be a challenging balance to achieve. So, air engines currently face some limitations, especially when it comes to range and efficiency. While they're pretty suitable for low-speed travel and shorter distances, their efficiency starts to drop off when you need higher speeds or more engine power. And yeah, that's mostly because the energy density of compressed air is a lot lower than that of gasoline, or even batteries. For air engines to really become a practical alternative for everyday use, there needs to be an infrastructure in place to support refilling those compressed air tanks, kind of like how we have electric power stations now. This could mean setting up entirely new refueling stations or maybe retrofitting some of the existing ones. Either way, it would require a significant amount of investment. Despite all these setbacks, air engines are definitely more than just a theorized concept. Actually, several companies and research institutions are actively developing and testing air-powered vehicles and machinery right now. For instance, PSA Peugeot Citroën developed a hybrid air vehicle that combines a traditional gasoline engine with a hydraulic system powered by compressed air. This hybrid system can switch between gas power and air power, optimizing efficiency and reducing emissions depending on the driving conditions. In urban settings where stop-and-go traffic is common, the air system can be used for low-speed driving, while the gasoline system takes over on highways or longer trips. Air engines are also being explored for use in other applications beyond the automotive industry. In industrial settings, air engines can power machinery without the need for electrical power or traditional fuel sources, making them ideal for use in remote locations or environments where emissions need to be reduced significantly. They're also being considered for use in submarines, where their ability to operate without oxygen is a significant advantage. The future of air engines will likely depend on continued advancements in several key areas, including energy storage material science and renewable energy integration. As research and development in these areas continue, the efficiency and practicality of air engines are bound to improve with time, making them a more viable option for a wide range of applications. Governments and private companies alike are investing in research to overcome the current limitations of air engines. For example, ongoing research into new materials could potentially make compressed air tanks lighter and more efficient. Similarly, advancements in renewable energy technologies could provide the necessary energy to compress air without offsetting the environmental benefits. The journey towards a sustainable future is paved with innovative technologies like air engines. While there are numerous challenges to overcome, the potential benefits make it a worthwhile pursuit. As research and development continue, the idea of seeing air engines becoming a common sight on our roads is no longer just a myth, and it may be what we need to set off the journey toward a healthy planet. In a world increasingly focused on sustainability and reducing carbon footprints, air engines represent a promising step forward. They offer a glimpse of a future where vehicles and machinery run cleanly and efficiently, without relying on finite and polluting fossil fuels. So next time you take a deep breath, remember that the air around you might just be the fuel of the future. What do you think about the potential of air engines as a sustainable alternative to traditional combustion engines? Let us know in the comments below, and we'll see you in the next video.